Hey everyone, so we are now done with the point plots and now we will move to distribution plots. So they are something a little important one and nearly all of the cases are analyzed by using these plots. So here we also going to need another data set, that is tips.csv, because that have much variable parameters, like these are all closed values. In tips we have different one. So here just change this diamonds into tips and here tips also. Now if you print the head, you will have this data set here in which we have total bill, that is the bill paid by them in any particular place they are. Then we have the tip, maybe they provide to the waiter, etc. Then we have their gender here, they are smoking or not, the date, that is weekday, the time and the size. And if you print this one completely, you will get that these are also varying, like here we have Sunday, then we have Saturday here, then Friday. The lunch and dinner are also varying and smoking status also varying. So don't just look at that one, like in head this is showing only these. So now let me move to the distribution plots. So here I have all these plots and most of these are distribution plots. So plotting the distribution plots, we have two different methods. That is, first is just by directly plotting the plots, second is by using the subplots. What I mean by that one, like if you look at here and see this one, you will get a joint plot, and if you go for this one you will also get a joint plot, and here also a joint plot. So what that mean? But if you look at them, then all they are different. So this is a plot, joint plot, that contain different plots. You can just involve the joint plot and change according to what you need. Second is just directly use them. So first let me show you an example of using a directly. That is, I'm going to use a plot that is known as residual plot. So for that I just need RISCD and then plot. Then pass the parameters, like I have x is equal to first one total bill, then I have the second one y, and this is equal to the tip. You can also just directly pass them, but passing with these is a better way. I will show you why. So here I have tips. If you shift run that one, you will directly get the plot. So here we have this one tip total bill and the variations according to that one, like with tip how total bill is varying. And you can have different parameters in this one also, like if you add low s, that will here be true, you will get a line also, this one showing the lower distribution. Now this is the plot in which you will directly get the output based on the parameters you are using. And if I talk about the joint plot, that is, just remove that one and the residual into joint, you will get a plot like this one, like a scatter plot. Here if you press the shift tab, you will get kind, and which is by default scatter. That's why you get here a scatter plot. This one is a scatter plot, like this one here. If you notice, this is a scatter plot and this is also a scatter plot. Scatter plots are just generally in which you have these dots scattered everywhere, and every of the point that contain plots inside it, like the joint plot that I am going to tell you here, is always by default somewhat that is given by the Seaborn, like here scatter. And if I do something here like kind inside this one kind and change this one into KDE, you will get a KDE plot. Here we have this one KDE. This one is different from the KDE line because that one is for only one parameter. Here we are using two parameters, so we have a closed curve. If you go for the gallery, you will notice this one is KDE plot, these closed curves. So these are generally defined into like 5 or 6 categories: bar plots, box plots, violent plots, hex, KDE, scatter, like that one. So here we are done with the KDE plot. And here is the one I prefer most, that is the hex plot, this one. Here you will easily able to analyze the data, like this one, these darker parts. This is the area where I have the more data. These are the parts where I did not have. And one more thing, these things that are shown here above and below, these are the point plots of particular parameter. Like this one is the total bill parameter in form of bar chart. This one is tip. And if you also notice here, we did not have any point on in last, and just this one on the last second. So here we have light parts. Here this one is maximum, and this one, and if you encounter them one here, like the intersection point, then this one is very dark. So this is the hex plot here. You can also make this one like this one. Just go to that one, check the color, like this is the color here, and this color subscript, that is hashtag 4CB391. This is the color code. Every color has a particular code with a hashtag followed by 6 character or number. That is a combination of both numbers and characters also. And you can get the color code just by googling. Here if I write this one and run that one, I will get the same like this one. So this is about this one, that how they work. Also be focused while you are writing these things that I have, like I am telling you in the residual plot, that why these important. Like if you do only this thing here, just a space bar, when you run you will get an error, and most of the time you did not get this one, that why I am getting error here. It also shows in total bill, but total bill is correct. I have this total bill. The error here is could not interpret input total bill, because the space is also considered in strings here. So make sure you are properly using the parameters. Also with joint plot we have this one, that is in last, this a regression plot. If you just make this one reg and run that one, you will get a regression plot. This is a regression plot in which we have a line, common line denoting, and above and below some parameters. And I will tell you more about this one later in the course, so just don't focus on that one right now. So we are on the hex plot, and here we have hex. So this is how you can work on distribution plots and how you can analyze them. You can get any one of these just by checking that which one is the distribution one, and can make them run here. So I hope you got the idea that how these work and understand these perfectly. Now in the next video we will learn a little more about this one and a similar to joint plot known as pair plot. So if you are feeling excited, then go and check the pair plot before checking the video, and rest we will continue in the next video. So thanks for watching. See you later. Hey everyone, so I hope you get that what the pair plots are, and if you don't get that, then follow the lecture. So we are now done with the joint plot. Here I have removed that one. You can also use any other .csv file here, like if we go for dots.csv now. So consider dot here, then this one dot, and dot, sorry, this one also need to be dot there, and there we go with that one. Here we have 1 2 3. Okay, that's fine. Now the thing here is what the joint plots are. Joint plots are something like they will plot every possible plot available in the data set. Like here if we have three numeric values, that is 80, all these 80, this firing rate and this coherence, then it will provide 3 into 3 9 possible combinations of the plots, that is time with coherence, time with firing rate, coherence with firing rate, and there with themselves, like time with time, time with coherence, time firing rate with firing rate. And maybe you get that one now. So it's simple, like sns dot pair plot, and just pass the data set like dots here, and then it will take a time, and then you will get this one. So here if you notice we have 9 possible combination, like time with time, then time with coherence, then time with firing rate, then we have coherence with time, coherence with coherence, coherence with firing rate, similarly all 3 with firing rate. So this one is a pretty one used to analyze all the data at once, and there are few operations with that one. That's why there's a separate video for the pair plot. Like here, if you have any non-numeric column, like if I print that one, here I have T1, T2. So here I have two things, T1 and T2, and in dots I have also two things, that is dots and sec. So I will consider the choice here. So now here, if you do not able to analyze the data, and second thing, if you analyze the data according to the choice, so here you can also include the parameters. Like the two parameters are already included. The third one you can include here is the non-numerical columns, and that is included by using HUE, and then pass the column like choice here. If you run that one, you will get different graphs with choice and T1 and T2 separately. Like T1 are those denoting blue, T2 are those denoting orange. And this one you will get like here we have choice and coherence, time and coherence, in which we have first all the oranges, and here we have also all the oranges. There is no blue, or maybe they are below them. So this is how you can separate according to any non-numeric character. More you will understand. Let me consider the first one also. That is just, let me copy this one. And one more thing, never upload or load any two types of data in the same cell, otherwise you will get error and your Jupyter notebook will get crash. So here I will have tips, and then this one tips, and then sns.pair plot. First I also need the column. So here I have tips.head. There we go. Now sns.pair plot, and then here we have tips, and I will separate them according to, like here this one sex there. So here I will write HUE, and this will be equal to sex there. Now if you run that one, you will get this one. Here the blue are denoting male, orange are denoting female. If you do here smoker, that is smoker, I also have two there, then you will get something like, let it process here, this one with the smoker and non-smokers. Why I have included tips now? Because tips have this day, which have more than two parameters, more than two options there. So if I include here day and run that one, then you will get all these pair plots separated with different days, like Thursday, Friday, Saturday, Sunday, that we have in our data set, and all they are in different colors like blue, red, orange, and they are written here. So that's how you can get a perfect visualization of the data, and that's why people prefer using pair plots, so that you will easily get this one. Also there are few things you can do with that one, like what if I need total bill and size plot in some other, like in dist plot or in scatter plot or in KDE plot, and I need these into any other different kinds, like I need total bill and total bill in bar chart. What I mean is something like, here you can also do few more things. That is, first I need to provide a variable here, this one in a variable, that is X, and okay, move with that one. So now hit return or enter on Windows, and if you are also doing the same thing that I am doing here, make sure you are doing again in same cell, don't use a different cell, otherwise it will not work. Let me also show you that one. Like here I use just X dot a map function here, then map underscore, and then provide where you want to have, like if I want to have all the charts here in the diagonal as the dist plots, like all they are in now KDE type, or I need upper one in that one, like if I consider upper one, then what are upper? These three are uppers that are above the diagonal, these three are lower, and this one is diagonal. So you can choose anyone, like if I choose upper here, then the parentheses, and then use SNS dot the type of plot you need. Like if I need dist plot, so here I have dist plot, run that one, and you will get error. That is something unexpected. No, not that error. Here you get the output. Base must increase monotonically when an array. So let me have here diagonal. That is DIAG, denoting the diagonal. And then run that one. So wait for that. Here it's processing. So here we get that. So if you notice here, we have the dist plot on the diagonal, and you did not get that same on the upper part. And the reason for that one is I am using the dist plot, and dist plot is a point plot in which you must use only one parameter. So here on the upper and lower triangular parts, I am getting two different parameter, but on the diagonal I have same, that is total bill, tip on this one, and what is on size and size on this one. So that's why I get the warning error when I'm using the dist plot on the upper. But you can use any other type of plot there, like let me show you. But before that, something else, like if you do this thing here, just run that in a variable, you will still get the pair plot output. Here it is. And if you try to run the thing now in the different cell and run that one, you will get error. So that's what you need to focus here. Make sure you are using the same plot. Now let me convert all the upper ones in the KDE plot. That is x.map underscore the upper, then sns.kde plot. Simple like that. And run that one. Now it's processing. Don't focus on this one. This is just that particular warning. Now here it is processing, giving me warnings, and there we are getting warnings and warnings again. Let me terminate that one and use a different cell. So here I have, sorry, we get that one also. So this is the one that we are getting here. The KDE plots are plotted here. Also the scatter plots, because I have not removed this one and plotted a pair plot there. So I hope you got the idea now that how the things work. You can also change the lower ones into KDE. That is, just write lower here and run that one. Now you will get that one. Wait for that one to be processed completely. Again warnings, and you can also remove that one so that you will just get either the KDE plot or the dist plots, that I will tell you later. So here we got the output line. Now we will get the result. So here is the result. Lower are the KDE plots and upper are the again scatter plots. Middle ones are the dist plots. So I hope you get this one now, that what the pair plots are and how they work. So thanks for watching. This one is a little boring one because get too lengthy, but this one is important one. So please stay focused while continuing this video, and if you did not get one, then go through the video again. So thanks for watching. I will see you in the next video. Hey everyone, so now we are also done with the distribution plots, and now we will move to categorical plots. So the categorical plots are those in which one axis is representing any numerical value or any numerical column, and the other one is representing any string column, that is like total bill tip on numerical and this text or smoker on the other. So we have various kinds of categorical plots also. Again, you can check them here and click any of these to verify that what type of the plot that was. So first of all, in the categorical plots also, we have the plots like point plots in which we require only one parameter, that is like SNS, and one of them is count plot. you just need to write count plot. Then we have our x is equal to any column that you need to plot, like I need to plot days, so here day. And the second one is the data, that will be equal to tips. Now if you run that one, you will get this one. This is a count plot in which we have 4 days, and here the count, and here we have the day. So this count is referring that how many times they are repeated there. After that, if you do this one with like smoker, then you will have only 2 plots there, that is yes and no. Here we also have time, not time, it's time. Then we have again 2. In this, if you try to add any more parameter, like if I add here either any numerical value, that is tip, I will get error. If you do the non-numerical value like sex here, you will again get error, because they are the one that use only one parameter. Now let's move to the 2, in which we require 2 parameters. So in that also we have categorized them at 2 different types. First is like that are using points, second that are using figures. So in points we have something like here. First let me begin with point plot. In that we again require 2 parameters. That is, first let we have, which one, consider total bill, first one, and then second we have any non-numerical column, that is like day here. And if you run that one, you will get something like that one, the example of point plot that I have shown you there, here denoting the days. And you can also change xy, like command x, this one here, and command v, this one, and this one is day. You will get this one, numerical value there, and strings here. This one is a little good to have strings on x-axis. You can also have here another variables tip, and if I have here smoker, I will have only 2 lines. So that's the point plot. Similar to point plot, we have another one that is something like this one, and that is known as factor plot, denoted by factor plot. So here you will get the factor plot, and it's nearly same as that one, just denoting 2 variables here, or we can say parameters. And you can also do with factor plot, like you can also provide kind here. This is something like joint plot. If you add bar here, you will get this one. If you add box here, you will get this one. This is the box plot that we are going to learn in the next video. So factor plot is something like joint plot. If you add here point, it will have that one, and by default it is also point. If you check shift tab, there we have, I think I lost it again, so leave that. There it is kind plot, you can also check there. So this is the point plots. After that we have some plots that are like scatter plots, which also point the points on the graph, but a number of points. Here we have only 2 points there. And if we use a swarm plot here and remove that one, we have this one denoting yes and no. And also the HUE command, if you need to have smokers, and you also verify that out of those who are smoking, which are men and which are women. So just add another parameter here, and you will get this one. Here the blue are denoting male and orange are denoting female. And if you are a like regular data science worker analyzing data, then you need to specify any particular plot for you, like one for categorical, one for distribution, and one for point plots. And then just have your own parameters. Like mostly I prefer in distribution the hex plots, and there I use the color that I have shown you there. Also if you use color here, I don't know why they are not showing here. You can also change their color, and there is another one that is known as palette, that is PATELLE, and I think this one is the spelling for that one, and I'm not sure about that one, but that we have a check here. So this one equal to like cool. Here we got the error because there is a spelling mistake. I know I mostly prefer to use colors, and this is PA, this one is L, and this one is T. I get confused in these two most of the time. So here we go. So here we have this one purple and light blue. So just like this one, I prefer this type. You can find your one that what you prefer. There are different options here, like if you do here magma, you will have, sorry, more quote here, magma, you will have this one. If you can add here cool warm, you will have this one. So I just go for the cool one because that's cool. And after that, this one is the swarm plot, and we have also used the hue parameter here. And related to swarm plot, just like this one, we have another one that is known as the strip plot. If you use a strip here, it's something like swarm plot, but it shows something in straight type, not everything surrounded here, like here we have the plots in that one. So these are the plots that are plotting data in form of points, as I have shown you all this one. You can also check other if they are available. Nearly all of them I have covered here. This one is rail plot. So if you are looking at that one, this is the swarm plot, and this one is the scatter one. So we are now done with that one. In the next video, we will continue with the plots that are under the categorical plots, but those who are using figure instead of these points. And I hope you will find that one more efficient than this one. So thanks for watching. See you in the next video.